In this lesson, we are going to learn about how to determine the molecular formula of a compound. First of all, a molecular formula of a compound shows the exact whole number ratios of atoms of each element in the compound. For instance, if I were to look at glucose, which is C6H12O6, so C6H12O6. For glucose, it would have 6 carbon, 12 hydrogen, and 6 oxygen. But then in the last video, we talked about a formula called empirical. That is, we can simplify this. If we divide all the subscripts by 6, that would give us 1 carbon, 2 hydrogen, and 1 oxygen, CH2O. And we call this chemical formula empirical formula. And if we look at the empirical and the molecular formula, their relationship in this case is that the subscript of the empirical formula is multiplying by 6. So 1 times 6 gives you 6, 2 times 6 gives you 12, and 1 times 6 gives you 6 oxygen right there. So based on the relationship between empirical and molecular formula, we need to know the following information in order to solve for this molecular formula. First of all, we need to know about the empirical formula. Sometimes our empirical formula is not given in the problem, but they give us the masses of each element in a compound, or even worse, they give us percent by mass of each element in a compound. And once we have our empirical formula, we of course can find the molar mass of the empirical formula. Because in the end, the only thing that distinguishes between the two formulas is their difference in mass, because there are different subscripts between the two. That's why it's important to get the molar mass of the empirical formula. And lastly, the molar mass of the actual compound or the molecular formula will be given to us. This will always provide it in some way. So those are the two information that we need to know to solve for the molecular formula of a compound. Then lastly, let's look at the number multiplied by 6. We call that multiplier. So to get from here to there, we had to multiply by a multiplier. And in order to do that, there is an equation, and it's all relative in terms of molar mass. That's why it's so important to get the molar mass. And that is, we take the molar mass of the compound. This is the actual compounds, okay? So this is the actual compound, or the molar mass of the molecular formula. And then that is being divided by the molar mass of the empirical formula. And of course this number should be greater than, and this would give you a whole number multiplier. So let's go back to the steps again. First, determine the empirical formula, calculate the molar mass of the empirical formula, calculate the multiplier using this formula, molar mass of the molecular formula or the actual compound, divided by the molar mass of the empirical formula. And lastly, we are going to multiply the multiplier, which in this case 6, to the subscript of the empirical formula. As you can see right here, if I multiply this by 6, 6 times 1 gives you 6, 6 times 2 gives you 12, and 6 times 1 gives you 6. And let's try a sample problem together. In this problem, I have an aldehyde that's unknown to us, and this aldehyde contains carbon, hydrogen, and oxygen. A scientist discovered that the compound has 40% carbon, 6.73% hydrogen, and 53.3% oxygen by mass. Notice we are not given the empirical formula, but we are given percent by mass. So we had to figure out how to find empirical formula from percent by mass. Now, if the substance has a molar mass of 60.06 gram per mole, what is the molecular formula of the substance? And of course, this right here is the molar mass of that molecular formula. So let's look at how do we solve this problem. First of all, we have the percentage by mass, and if we assume that this is out of 100 gram, we can take that percentage and convert it to mass. And of course, we have 40 grams of carbon, 6.73 grams of hydrogen, and 53.3 grams of oxygen. And the rest is just basically using our stoichiometry to solve from gram to mole. And here are the molar mass from the periodic table. Notice how I have grams on the bottom to cancel out. Gram cancel out, gram cancel out. And give us our number of moles right there. And why do I divide all the moles by 3.33? Because that is your lowest number of moles. Because we want to compare our moles in terms of the lowest, so that way we have the ratios of whole number. And it turned out, give us 1 carbon, 2 hydrogen, and 1 oxygen. And this is our empirical formula, abbreviated with AF. Okay. So we figured out our empirical formula. The next thing we have to do is we have to find the molar mass of the empirical formula. And that is pretty easy. Use a periodic table. And then here we go. For carbon, we have 1 carbon multiplied by the mass of carbon, 12.01. Hydrogen, we have 2 times 1.01. Oxygen, we have 1 times 16.00. And we multiply. This is the total mass for carbon. This is the total mass of hydrogen in this compound. And this is the total mass of oxygen in this compound. Give us 30.03 gram per mole. And that is our molar mass for the empirical formula. The last thing we have to do is, well, the next step is to calculate for the multiplier. In this case, the equation is this. It is the molar mass of the compound, which is given to us. In this case, we look back, it is 60.06. So our multiplier is, let's call our multiplier M is equal to 60.06. And this is being divided by the molar mass of the empirical formula, which is, we just figured out, where is it? 30.03. So we have 30.03. And that gives us, if we plug this into a calculator or not, that gives us 2. So what do we have to do? All we have to do is multiply this multiplier to all the subscript. So that tells you there are 2 carbon, 4 hydrogen, and 2 oxygen. This is our molecular formula, or MF, given the exact whole number ratios of 2 carbon, 4 hydrogen, and 2 oxygen. Let's do another sample problem. In this case, we have the same scenarios, okay? But the only thing that's changed is the molar mass of the actual substance. Now, going back to our previous problem, we have the empirical formula right there, right? So our EF in this case is CH2O. And we know the molar mass of this empirical formula is 30.03 grams per mole. Okay? And all we have to do is, in this case, find the multiplier. And again, let's go back to the equation. The multiplier is equal to the molar mass of the actual compound, or the molecular formula, divided by the molar mass of the empirical formula. So this case is 100. We couldn't call M as a multiplier. So M is equal to 180.118 divided by the molar mass of the empirical formula, which is 30.03. And that gives us 6. So all we have to do is multiply this by 6. That gives us 6 carbon and 12 hydrogen, and then we have 6 oxygen. Isn't that easy? And that's all we have to do to find the molecular formula of any given compound. But first, we need to know about the empirical formula so we can find the empirical formula molar mass. And secondly, we need to know what is the molar mass of the actual compound. So those are information that we need to know to solve for the molecular formula.